So just to speak of the menstrual cycle in words, and then I'll use the diagram in the next slide. It takes about 28 days. There's going to be variation within those 28 days, but we'll just break it into a 28-day cycle, and saying that ovulation is occurring at about the day 14. When we look at the menstrual cycle, we're looking at a non-pregnant female, so no fertilization is occurring here. So, contrary to what people might think, the beginning of the cycle is in fact the flow phase or the menstrual phase where the endometrial lining is shed, and that's about days 1 to 5. And again, variation can be common in that as well. We're going to say it's about days 1 to 5, and that's where the endometrial layer is shed. It produces menstrual flow. It is basically the time of the period. The follicular phase falls in about days 6 to 13, and that's when the follicle matures due to that hormone FSH. And one follicle will develop the fastest if we're talking about a typical cycle, and that is a follicle. Estrogen being responsible for the secondary sex characteristics, as well as for the stimulation and vascularization of the endometrium. Estrogen at high levels is going to cause release of LH from the pituitary gland as a positive feedback. And LH will peak around day 14. And that's going to essentially cause this third stage here of ovulation. And that's at or around day 14. That's going to be the release of the ovum into the fallopian tubes, and it will move down the fallopian tubes towards the uterus. It needs to get fertilized within the first third of the fallopian tubes in order to have a potential for successful implantation. So that follicle that the ovum was inside maturing is now empty. It stays in the ovary and it forms a structure called the corpus luteum, which takes us into the luteal phase. The luteal phase falls around days 15 to 18, and it's called luteal phase because it's marked by the development of the corpus luteum. Estrogen levels will decrease when the ovum leaves the ovary, but it picks back up. And so the estrogen levels will stay high, and the corpus luteum will also secrete a hormone called progesterone. So the two functions of the hormones here, estrogen stimulates the endometrium and prepares the uterus for an embryo. High estrogen level also has a negative feedback effect on FSH, and so that will prevent the formation of another follicle because we only want one at a time here. Progesterone prevents uterine contractions or maintains the endometrium and will also inhibit ovulation because it's telling the body that ovulation has already occurred, because progesterone is only released once ovulation has already occurred. So if fertilization doesn't occur, so we've got a non-pregnant female, the corpus luteum will eventually degenerate and disintegrate into a small scar called the corpus albicans. LH levels will drop, causing the corpus luteum to disintegrate. And then the corpus luteum, which we know is secreting estrogen and progesterone, will now no longer secrete those as it has disintegrated. And those levels drop. You'll get weak uterine contractions, which essentially causes the endometrium to pull away from the uterine wall, resulting in menstrual flow again. And we start back at the beginning. If we follow that in this table here, or in this chart shows you all of the areas that are involved in terms of the menstrual cycle. So here we have the hormones of the pituitary gland, the structures of the ovary, the hormones in the ovary, and then the uterine lining or the endometrium, and then just the days of the cycle in terms of what they're called. The pituitary releases the follicle-stimulating hormone and the luteinizing hormone, remembering coming from the hypothalamus, from the signal from the GnRH. So this is showing sort of the general effect of FSH and LH on the menstrual cycle. FSH initially, in reality, really just goes up at the beginning and then falls down, sort of peaks, and then stays down. If we're going to say what FSH truly does, LH will stay low. Let me just get another color here. Will stay low, and then it spikes around ovulation, and then it kind of drops again. So this is what LH would do. But with the way we have it on this graph here is really showing you how it affects what's going on, because sometimes LH can be stimulated by estrogen when it's at a high level and inhibited by estrogen when it's at a low level. So if we look at what's happening in the pituitary gland, the first thing that goes up is the follicle stimulating hormone. So you can see that it's gone up a little bit. So as the follicle stimulating hormone goes up, and we can just imagine that it's going up because that just helps us understand this process. We can imagine that it's going up. The follicle stimulating hormone goes up, and that's going to trigger this follicle development to happen. As the follicle matures, estrogen starts to go up. And as estrogen starts to go up, it's going to start having a positive feedback on LH. Now you can see in this one here, it shows LH going up. That just helps us understand this idea that it's affecting LH hormone. But it isn't until a point along the estrogen where the estrogen gets so high that you're going to get this shoot straight up of LH. And that's an indication that we have a mature enough follicle because it's secreting enough estrogen, putting enough effect on the LH to cause this ovulatory process. So now the ovum is getting released, and you can see in this illustration, it's heading down towards the endometrium. The corpus luteum is what's left over in the ovary, and it's going to secrete estrogen and progesterone, and we can see progesterone levels have risen here. If we look at what's happening in the uterine thickness is getting thicker over time. So here was menstrual flow. That's about days 1 to 3, which we'll see also back in here, days 1 to 3. It sort of overlaps on each side. And you can see the endometrium is getting thicker and thicker as we move along. That's because of estrogen. And then it's being maintained over here. So this is sort of the prime spot around the number of days, maybe 21 days, where an a fertilized egg could implant into the uterus and have a good chance of taking, right, and causing a pregnancy. But female, there'd be no signal that the body is pregnant. So there's going to be a hormone that's released from a fertilized egg that would actually keep all of this process and all of these things intact along the way. So what would happen is if this was a fertilized egg, it would keep LH up, which would keep the corpus luteum intact, which would keep these hormone levels up. But that's not happening in this case. So there's no signal the body is pregnant. LH has a drop, and it dropped anyway. The corpus luteum is going to turn into the corpus albicans, which is then going to decrease the secretions of estrogen and progesterone, and particularly progesterone causing uterine contractions, which will cause the menstrual flow and the loss of the endometrium. When we name the phases, the menstrual phase or the flow phase is what the period is essentially called. The follicular phase is when the follicle development occurs, and the luteal phase is where the corpus luteum is the dominant structure in the ovary. So that's the menstrual cycle in terms of looking at what happens in each of the structures, including the endometrium and the days that are involved.